Good. I hope everybody sees my screen and luckily myself too. So I'll be talking about like cryptography and blockchain, and this topic will be interesting for developers, for people who are interested in cryptography, who want to know more about these things work. Basically, uh, for anyone who is involved in blockchain but wants to understand like some foundations and principles behind the all these concepts. A little bit about myself. I've got PhD in cryptography. I was developer in some companies, like project manager. In 2015, I went to Silicon Valley. I joined Stellar, and then my life completely changed. So I also used to work in Singapore as a cryptographer, and since the end of 2014, so for more than 6 years already, I'm a co-founder of Distributed Lab, doing what CEO job currently. We are 70 plus people. We are doing a lot of research and development in blockchain space, such as like consulting and R&D. And our goal is to build financial internet. That's the final like thing. But I'll be talking about this a little bit later. So as a team, we've done quite a lot of things, like in research, participation, hackathons. I've been virtually like everywhere, basically except Miami. But hopefully, we'll be there this year. We have a product. We're talking about this later, and we've published like 5 books about blockchain. 3 of them are officially recognized as textbooks in Ukraine, and 2 about one about financial internet, one about how to build financial platforms. Then our agenda will be that first, so to say, anything you want to know about crypto and blockchain, some pieces of like advice why to use blockchain, a little bit about like ICO and utility tokens, like criticism and rationals, and then we'll talk about tokenization, about crypto assets in general, and about smart contracts and how they are related to cryptography also. Okay, so the map is that we'll be talking about blockchain, about cryptography, consensus, cryptocurrency, some about like key management and smart contracts and utility security tokens. First, cryptography. For those who don't know cryptography, it's sometimes like some mystical area of usage of like mathematics, and it's kind of sometimes it's weird. So you can do things that you wouldn't yourself imagine, like for example, like zero knowledge proofs look completely crazy, as well as like homomorphic encryption. Other things are more or less like straightforward, such as like encryption. Yes, kids, people used like some very simple encryption in their messages, mixing letters or doing some kind of basics of steganography, so to say. The basic concept of cryptography is existence of one-way function, which means that um, doing calculations one way is very easy, but calculating the input from the result is extremely hard. So without one-way functions, the cryptography wouldn't be possible. And then the second thing is that certain one-way functions, they have keys. So with the key, calculation of the input having the result becomes easy. And this is used in encryption and digital signature. And one of the best examples of one-way function is hash function, which is just a digital fingerprint for some data. And hash function is extensively used in all the so to say, blockchain applications underneath. There are many standards for it, but for now, it matters that it exists. And then we have a concept of a public and private key, which means that you use different keys to encrypt the message and decrypt it, and you use different keys to sign the message and verify the signature. So this is basic concepts. And zero knowledge proofs. Um, these are certain like mathematical algorithms that allow you to prove that you know certain data, for example, the key, without revealing the key itself. So you can even prove in some cases that you paid taxes without telling how much or to whom or to something like that. Okay, we have quite a lot of myth in cryptography, again, from people who don't fully understand it. And the first one I was specifically asked to address this one about quantum computers, that like quantum computer will break uh, all cryptography in Bitcoin or crypto. And immediately, this is a myth. So, like, indeed, there are cryptographic functions that are obsolete or will become obsolete as soon as quantum computers appear. But it doesn't mean that all cryptography will be obsolete. So the problem that Bitcoin will face, first of all, even will be even more dangerous for the banking crypto, because Bitcoin has already certain levels of protection through quantum computers. So if you didn't use your UTXO, nothing will happen. But the second thing is that as soon as we will be close to quantum computers, there are already plenty of quantum computer quantum cryptographic algorithms that that are not vulnerable and that can be implemented in Bitcoin or other crypto. So it is about it's like Bitcoin uses SHA-2 hash function and MD5, and so to say, like SHA-1 hash function is considered to be weak and could be broken already with existing uh, comp- computing capacity, which means that the creator of Bitcoin has selected the hash function that is more or less that is secure, up to date, and didn't take the unsecure function. So the same process will happen with time, so they will be updated. The second myth is that the public key itself needs no protection. It's kind of that's a myth. So even if public keys need a lot of protection. So just a simple example: when somebody is sending you crypto, you have to tell them the address from Bitcoin or Ethereum or any other crypto. And if you send it through some messenger and this messenger is not secure, so the address can be substituted. So the crypto could come to the address of adversary. So this is the easiest problem. So in ideal world, you have to sign your address with some digital signature, or you need to use the second channel to verify that the recipient got the same key, that the same address that you've sent them. You can use phone, or you can use like two messengers. So if you don't trust any of them, you send your address through two channels, and if they match, then it's fine. Yeah, unless your all messengers broken, then it'll be fine. Then you should never write your own cryptography unless you're a cryptographer with 30 plus years of experience and working in the research organization. And many people did this mistake. They tried to build their own stuff, and that's hard. Checking the sound just in case, because I don't hear any feedback. Okay, then the next thing is that people think, oh, if we use encryption, we are secure. No, encryption is just one small piece from the variety of methods that are available, again, such as digital signatures, zero knowledge proofs, and other protocols or key exchange, and so on and so forth. And majority of breaks didn't happen because of weak cryptography, but first of all, because of like social hacking, your passwords are written somewhere. Second, that could be that the protocols are not secure, like key exchange, some other stuff, and only then it's about real cryptography. So definitely, if you use encryption, it's not just a panacea, it's just one building block. You have to be aware. And people also believe that cryptography is always safe. Again, ways the every 10 years, uh, you should more or less change the algorithms that you are using because new ones appear and old one becomes obsolete for some reason, whether it's not kind of not vulnerable to computational capacity or some errors are discovered, bugs, etc. Okay, then we come to decentralization, which is there is a nice picture. I didn't omit it here. Everybody knows that, but decentralization is much deeper than just having uh, many components in different places. Decentralization, the deep one, means that a lot of processes such as like governance, identity management, asset management, communication, storage, um, computation, and audit are decentralized. Plus, on top of that, you need a social kind of say social consensus or social decision making also decentralized. So one of the example, like Bitcoin is considered to be decentralized, so to say Ethereum as well. But what if somebody, and we had these situations, uh, takes the full fork of Bitcoin and does all the mining themselves, replicates all the transactions, simulates all the activity, but runs it on a single server? It's easy to imagine, and in that case, you have full code of Bitcoin. You can simulate to run it on a few machines. You simulate the activity, but it's not a decentralized system at all. So it's and many people accused some Bitcoin forks, and not only Bitcoin, that governance is not decentralized. That in reality, like all the processing of transactions, all the mining happens on one server, or so to say. And kind of it shows the problem that even if all criteria from on the surface are met, it doesn't mean the system is decentralized. So decentralization is a very hard price. It should be achieved, with gradually. So when Satoshi launched Bitcoin, it wasn't decentralized. Well, a few people running that. I mean, it became decentralized, which is a great achievement and, so to say, luck. But we need to think always about governance, identity management, asset management, communication, storage, processing of transactions, and audit, and social consensus, super important thing. So there are also certain myths like about decentralization. And first is like, what if we decentralize storage and transaction processing, that it's enough? No, it's not enough because governance is a super, super important thing. Usually it fails here. So many of you, I'm pretty sure, know about crypto projects that have very strong founder. And when something happens with the founder, or yeah, some decisions come to their mind, then the whole project is diverted or stopped to be developed. Second myth is quite surprising for such an audience, is that decentralized systems will replace centralized. It's definitely a myth because it's like saying that the square will be replaced by a circle because circle can be used as a wheel. So, yeah, and square cannot, can build car using squares. So each system, each approach has its own application, and like you need to first analyze the environment, build a security model, and only then see what you can apply here. So some, like many people in 2017 believed that all organizations have to switch to blockchain and have to run their transactions on blockchain because it's more secure and so on. But the simplest example, what if you have a warehouse that stores like tomatoes, and yeah, somebody convinced them to move to public blockchain, decentralized, and so on. And will the token that representing the like 1 kilo of tomatoes more secure than the paper receipt? An answer is very interesting. Like if tomatoes are rotten or they're stolen, that the token has no additional value compared to piece of paper because the risks are completely outside of technological system. So only in systems where multiple participants can truly run uh, the whole thing and verify all the data, like in Bitcoin, for example, it has no physical touch, then it makes full sense. But if we are talking about the system which requires trust, and again, the tomatoes, like some asset is not stolen, yeah, rotten or whatever, only uh, like these systems can enjoy centralized approach and to be fully fine. Although they can use private blockchain or they can use cryptography, it can use the APIs and open APIs and so on and so forth. So basically, it's about again the second um, side of the scale is people say, "Oh, we blockchain is not needed in traditional systems because it doesn't add any value." And the answer is also no. Like you like cryptography is will be needed everywhere, and blockchain is the way to organize like transactions and data, and also could be used quite a lot of traditional things. And last thing is like decentralized systems are all similar, which kind of forced people to invest in, so to say, an asset class. So we'll touch this question later, but uh, they meant that, okay, all tokens are more or less the same asset class. Let's take top 20, invest, and let's see. For those who think like that, look at the top 20 in 2013. You'll see that majority will just die. They're not just slower, they're obsolete. Okay, one thing that allows you to, maybe not you, but if you kind of explain to your friends the decentralization, the best example that they found is like card game. When I often explain like Bitcoin, and people at the end ask me, "Oh, but what if Satoshi changes rules? Or what if they print more Bitcoins? Or what if they do this? Or what if they do what?" And I say, ask them like, who will do that? And say like the creators or those who manage the system. And then I provide them with example, like look at the card game. Everybody played card games. Like, can the creator of poker change the rules of poker sitting at home? Like, do you even know who created poker? I say like no. But can the creator affect rules in a particular game? No. Can the creator substitute cards or print more cards? No. Can the creator, even if the creator is playing at the table, do they have an advantage? Like, not really. But how the transactions are processed? Like, people together who sit on the table look at what's going on. And if they see that some rules are, broken, somebody is using more cards than they should, it's just a social consensus at the table, and yeah, people will exclude that participant. And this is a truly decentralized system. Just when digitized, it becomes really efficient. So that's all the essence about Bitcoin and blockchain. It's like how the transactions are verified by many participants and how the rules established at some moment of time in the past can be followed and verified by people now. That's the essence. And one thing to just attach it to, so to say, digital assets, I put here a scale which shows that decentralization can have multiple levels, and all these systems are needed, and all systems have their own benefits and drawbacks. So, for example, like cryptocurrencies like Bitcoin has quite advanced level of decentralization, but I think we'll see other type of cryptocurrency that is even more decentralized, that uses mesh network which is not controlled by internet service providers, where applications are not installed through like Google or Facebook or like Apple or Microsoft, but can truly, yeah, work in such a network. And there are already systems that have certain features. So, for example, one of the feature of the fully decentralized system would be that the fact of the transaction is not obvious to the observer. So the transaction happens, but nobody knows that it happened. So to such an extent, like Monero and Zcash, yeah, and Mimblewimble have this function. And on the other side of the scale, we have like digital ownership, which again could be I can have a digital warehouse receipt from the, yeah, tomato warehouse, and we don't need really decentralization here. We need just the proof that this receipt is mine and it was issued by the warehouse. Then we have reconciliation between a few parties, also decentralized. Then we have kind of tokenization of real assets. We have voting, which could be like countrywide, and will need many nodes to kind of do counting. So different ways of decentralization. And we as a company, we build all of these things. I mean, when clients ask, and we specifically apply different tools, yeah, for that. So the next topic would be consensus. It's a very important topic, which often leads to like myth, and which leads to if somebody just learns like solidity and haven't seen anything else in their life, it would be, very hard to imagine that like other concepts exist and they're also useful. So there are a few types of consensus. In general, like the most generic types are proof of work, proof of like kind of proof of stake, and variations like DPoS, proof of importance, proof of authority. To a certain extent, they also kind of a stake. Then we have federated Byzantine agreement and yeah, BFT, just Byzantine fault tolerant, BFT. So the one myth that I would suggest here is that many people say that this consensus is better than something else, and this is not true. It's just the conditions in which this consensus operate are different, and that's why they need different, yeah, things. It's like asking what is better, apples or pies, and pears. The question doesn't make sense. It depends for whom and what kind of vitamins you're looking for, or taste, or something like that. So the proof of work, to a certain extent, can be shown through an example of like citizens that want to vote for, what to do next with their houses, whether to install the the fence, or fix the roof, or do something else, and they need to vote. But this voting will happen through some work, which can be completely unrelated to what they're voting for. So, for example, they kind of do kind of a lottery. They kind of use the tram, and they take tickets, and whoever ticket has the lowest number has the right to suggest a decision for the particular problem of the day. So if I go to the tram and I buy a ticket that has 3 zeros, 6 zeros, I won today. And they all kind of compete on this. It's basically exactly how Bitcoin works. And whoever buys more tickets has the bigger chance of taking the lowest number, the ticket with the lowest number, and therefore has the higher chance of suggesting what should they fix that day, which problem should they solve. And that's why it's called proof of work. So you need to invest more money to increase your chance of winning. Even if you're buying 100 tickets and somebody else is buying just one ticket, it's not 100% win. It means that you have 100% chance more than somebody else, and obviously there are others in winning, but you don't have an absolute proof. So Bitcoin uses this method because it's hard to trick. So Bitcoin uses solving mathematical puzzles for which you don't have an efficient algorithm. You need to use brute force. It's like similar to buying these tickets with money. The second algorithm is more like voting of stakeholders in some company, so board directors meeting. So whoever has more bigger stake in the company has higher chance of solving or of suggesting a decision or doing something. And obviously, if people kind of group together, they have an higher chance. But even if somebody has just 1% of the stake, at some moment he will be hurt as well. So it's not a voting with the power. It's more like how do we distribute the chance of somebody suggesting the decision for the problem. So that's how proof of work works. And the important thing is that in cryptocurrencies, proof of stake means that you have to deposit and freeze your internal coins in order to participate in such consensus algorithm. And the last is two algorithms on one page, and one is FBA. FBA algorithm is Federated Byzantine Agreement, allows you to reach consensus within very large group of people who don't know each other, and they only know some people. But if people have intersections in their relationships, eventually algorithm allows you to spread the consensus along the bigger group. So you need to know only a few people, you need to trust them to a certain extent and validate, and they know other people, and that's how, if these relationships intersect, trust circles, then you can reach global consensus. So you can think about this in a case when all notaries in the country, they support together a land registry. So each notary knows other 5 notaries, and each of that 4 knows somebody else, and also some groups. They form some groups and they reach consensus. And BFT means that you need to have a small group, limited group, which is usually fixed. And everybody in the group knows each other and they need to reach consensus. In the condition that somebody might be tricking them. So this is what's going on in BFT consensus. You need a limited group of people who trust each other. And obviously, it's the most efficient algorithm because you have limited amount of connection. So if to sum up, then proof of work allows you to work with unlimited amount of like consensus participants that don't trust each other completely. Then proof of stake let you like work with unlimited amount of participants that to a certain extent trust each other because they see the stakes and they see the consistency in voting. You have some algorithms that protect the information about who owns the stake, like Ouroboros, but it's more like new stuff. Then FBA, Federated Byzantine Agreement, allows you to reach consensus in the large group where people have identity but don't trust big group, but trust only small group, and this small groups intersect. And the BFT works in a case where everybody knows each other and they, so to say, trust each other and can punish each other. Okay, then we'll shortly review the security model concept, and we'll talk about the weakest link concept, confidentiality, integrity, accessibility, non-repudiation, and the importance of the key. So quickly come through this. These concepts are very important for blockchain projects. Yes, for all cryptography projects in general. So the first one is the weakest link concept, which means that the system security is characterized but not by the strongest security tool, but the weakest. So it's the easiest example is like the house, which is built from wood, and you installed on this very strong like steel door. So this door can maintain the explosion. But then if you have this house from wood, it could be easily burned, or intruder can come through the window, so to say. So it doesn't matter how strong is the door. It matters how strong is the weakest component. The second is that like it's concept called CIA, confidentiality, integrity, and accessibility. These three features of information of security are super important, and they're completely different and use different like tools to protect themselves. So confidentiality is about protection of information from unauthorized person access. Integrity is about like how do we control that some information was changed or deleted or is coming from untrusted source. And accessibility is one of the things that underestimated is like how do we ensure that information that is important can be accessed. So what if we have super critical information, but then the server with it doesn't work? So the importance of this information just is diminished. Then the other piece is non-repudiation. Also, like important thing is like how do we prove that somebody did something in the system, whether it's administrator or it's maybe a user. You need to have a proof that it's about like identity. Then the last piece of security model is that the whole system can be completely transparent, like open source, all the algorithms described, even communication between system modules is monitored by hackers. But if key remains secret, then the system should be secure. So this concept was introduced like a few decades ago, and it completely changed the perception of secure systems and led to development of truly secure ones. So because many people believe that if they obfuscate the code or if they keep the algorithms in secret who develop the encryption algorithms themselves, it will add more security. Not at all. So they should stay with the model of transparency and the secrecy of the key. Then a few myths. So if somebody spends a lot of on security, then they're safe. It's not, true, because they can spend on the wrong piece. Yeah, as we saw in the example of the door. Or if the company uses firewall, I mean, again, it's just one piece. Or if somebody doesn't know the security mechanism. So these pieces, this myth, are very dangerous. So you should stick to the kind of important part on confidentiality, integrity, accessibility, thinking about the like reliable algorithms that maintain the secrecy of the key, the private key, and everything else is just entourage. Okay, we're coming to blockchain piece. We're thinking about like what's important in here. And first, I would say terminology. Like everybody knows about that, but I will just do like a common ground. So blockchain is a secure method to store and synchronize data between parties who don't trust each other. And which means that blockchain is not even a technology, it's like a more like a method. And if the parties synchronize it within the trusted, more or less, so to say, trusted environment, it doesn't mean they don't use blockchain. They don't need to use blockchain. They should. It just there will be a special consensus algorithm, special cryptography from the one that is used in Bitcoin. So in any use case where people do not fully trust each other and need to communicate and need to synchronize some data, they will be eventually using blockchain. So that's what I believe will happen. That's why I bet on this space a lot, because I think it's hugely underestimated, the role of blockchain in general. So there are many myths again about blockchain. First is like it's slow and requires a lot of energy. I will be quick. It applies only to Bitcoin, or only to current cryptocurrencies that are using proof of work. They indeed are slower and use a lot of energy, but it's for a reason. They achieve certain security level that others cannot achieve. And security, not just unbreakable ciphers and signatures, but about like true like decentralized decision making, which cannot be achieved in currencies that use like sort of BFT algorithm, such as like Ripple, which is not fully cryptocurrency in full sense. Then people believe that blockchain is immutable by itself, like for some like magical reason. It's also not true. Because immutability comes with the context. It's not about just mathematical thing. Then people think that data in blockchain is always correct because it's checked by everyone. Nothing is far from the truth. You can add to blockchain random data or some stupid things. Everybody will check it, but don't have the ability to check the essence of the data, only the numbers. Most the laymen believe that any blockchain is vulnerable to 51% attack. Again, it's only to crypto that have um, algorithms that have the proof of work, specific proof of work algorithm, or proof of stake that is 51% to say vulnerable. Many people think that any blockchain needs miners, even if they build private blockchain, who will mine my chain? These questions appear from the poor understanding of what consensus is. Yeah, we talked already about that quantum computer will kill blockchain. So short comment, no, it won't. And the blockchain for centralized databases is not no better. Like blockchain for enterprises is no better than centralized database. We'll touch this piece. And the last thing that I've seen that any blockchain requires their own coin or needs an ICO. So these were my top that I've encountered. I'll be very quick on why do we need blockchain at all, like in any particular use case. And the answer is that currently the data that comes from any source can be truly trusted. It's hard to validate. So with papers, we already established, like people already established some protocols. So the paper needs to have some, yeah, signatures or other symbols on it, and then it could be somehow be verified. With digital, usually it's like you see digital piece of digital data and yeah, data, and that's it. Uh, and with blockchain, you can truly build system where you can validate the data and see where it's coming from, who issued it, and that it wasn't changed on the way. So eventually, using blockchain, you can build a single source of truth for many participants that have to cooperate. So Bitcoin is indeed the example of this single source of truth, where millions of people have access to the same version of the ledger real time. And eventually, any blockchain-based system can become a foundation for settlement. So you don't need to use some manual approach, semi-manual to settle financial data or something else. Like blockchain itself is the algorithm for settlement. It's like email protocol encapsulates the delivery component and yeah, many others. You don't need to think about that. Regarding the war blockchain versus centralized database, I have some arguments that, like even for centralized use case, you still have a lot of benefits, such as like trustless real-time audit, such as integrity control, robustness, accessibility, non-repudiation, and distributed decision making. So all these pieces, if you try to achieve them with a centralized database, you will eventually build blockchain, your own version. So it's kind of centralized database on steroids, which not just database, but the system to maintain such things as integrity and non-repudiation, robustness, and so on and so forth. So it's truly a progress. So yeah, as I mentioned before, uh, blockchain is helpful not just for cryptocurrencies, but also for yeah centralized things. Um, I'll probably skip the problems because I wanted to come up with I'll just read the title. So business problems that blockchain helps to solve is like trustless registers of ownership, identity management, secure reconciliation, trustless decision making, and trustless audit. These are things that are most yeah, likely to embed blockchain, as well as like timestamping. And I think that blockchain will be heavily used in supply chain management, in public registries, in reconciliation, in voting, and decentralized trading. These are, yeah, I would say use cases that will be transformed really fast. Okay, we'll skip the auction part. Okay, a few words about cryptocurrency because, like, yeah, super important. We have time that's short. So, cryptocurrency, uh, it's a digital asset management system where you have like 8 processes decentralized. the processes that we talked before, such as like audit, processing of transactions, such as storage, and the identity management, governance, and so on and so forth. So as soon as you have digital asset management systems where you decentralize all these things, you can think about your system as a cryptocurrency. Also, it should be permissionless, so you don't have anyone who you need to ask the permission to initiate the transaction, or nobody can stop the transaction from execution. It's a super important property, and actually, it's the single criteria that tells you that it's cryptocurrency. It's closely related to censorship resistance. So if you have a something, crypto, so to say, system, and it's not censorship resistant and not permissionless, it's definitely not a cryptocurrency. So by this definition, XR Ripple is not cryptocurrency. It's a digital asset management system, but it's not a cryptocurrency. And last thing important that in cryptocurrency, like everybody involved in everything, so everyone can become an auditor or validator or a storage provider and participant in decision making. So kind of there is no like ranks, so to say. There are many myths about again cryptocurrency, and one of the funniest and the first is that like coin market cap lists cryptocurrencies only because you have multiple asset classes there, and most of them have nothing to do with cryptocurrency at all. So they could be digital assets, digital stocks, and so on and so forth. The second is like a coin means token means cryptocurrency, just a naming problem. So the coin and token are more like coin is a layman term, token is more like a technical term, and cryptocurrency is like, I would say the new paradigm in currencies. And people believe that cryptocurrencies will replace all intermediaries. Not all, but only some. We don't have time, unfortunately, to talk about all of that. We addressed already the myth that the creator of a decentralized system can print more, change the rules, control the system. Not at all. And the last one is more funny, that people believe that the crypto price will always be growing. Even though it wasn't like that, some people say no, but the long term, it will be growing because it's scarce and because it's crypto. It's not true. The price is affected by supply and demand. So it's only if the cryptocurrency, a particular currency, is used more and more and more, then it will be growing. If no, it will be stagnating. So if tomorrow we have much better Bitcoin, then original Bitcoin will kind of price will decline. Or if less people will be using it for some reason, so it definitely has so the inflation has nothing to do with that. It's just one factor that affects supply and demand. And the last thing like depicts the again interesting situation that currently most of the decentralized systems are accessed through fully centralized systems, such as Google and Microsoft and Apple, and it's problem that they can shut down whole networks by closing down access to them. A few important things about like what Bitcoin has taught financial industry in general and IT community. And my favorite is that until now, people believe that in order to protect a database, like a bank or some financial system, you have to maintain the physical security. You need to have firewalls. You need to have security administrators and some other physical like walls and only then it will be secure. And like many people are still living in the paradigm of security perimeter and saying that secure systems should not have open APIs or should not be open source. The Bitcoin showed that this point of view is obsolete. Bitcoin is open source, fully transparent, has zero security administrators, no firewalls, and at the same time, you cannot come and steal all the Bitcoins from Bitcoin network. You can attack an exchange, it's true, but you cannot steal, attack the Bitcoin network in such a way. So it shows the power of cryptography. It protects the integrity of accounting system and prevents attackers from doing bad things. It's just many other applications, banking, finance, and registries can enjoy the same level of security if they use these things, such cryptography. That's why we always have a lot of job because we'll be substituting the expensive measurements, um, consume a lot of manpower. We'll substitute with cryptography. So exciting times are coming. And yeah, this is why many organizations are still employing the concept of security perimeter, like a secure organization where you cannot come with your own flash drive. You use only dedicated computer. Now these things obsolete. You need to use a new concept. Like the COVID showed that okay, now everybody has to work from their homes, from their devices, and you cannot protect it just by having VPN or something like that. You need to use some other methods. Okay, we have just 1 minute left. I guess I will be wrapping up. So we have a lot of material, but it's bad that time is left. So I'll show one last slide about some classification of digital assets that you have cryptocurrencies, you have digital currencies, which could be auditable or could be non-auditable. Auditable could be like Ripple, non-auditable like PayPal. You have tokenized assets such as Tether. You have digital assets in general, which could be not be auditable, and yeah, you have very few real cryptocurrencies. Although I have nothing to do, nothing, yeah, nothing. There's nothing wrong with XRP, for example. They're just, for example, building the ecosystem where their asset is a transactional one, so the currency. So every country effectively trying to put their currency and maintain their exchange rate. So yeah, there will be communities like online games which will introduce their own currencies and will be acting the same way as XRP, for example. Okay, my time is up. On the you see my email. It's pavel@distributed.lab.com. If you have any questions or commercial projects, yeah, anything we do, we teach a lot. Our books are on Amazon, some lectures on on YouTube, and we do a lot of R&D in this space. So thank you for your time. Sending hi to Miami, and wishing good luck to all hackathon participants.